Hi everyone. In this video we are going to see how to find the equation of the family of circles touching a given point on a given straight line. So the equation of the straight line would be given, the coordinates of the point would be given, and we have to find out the general equation of all possible circles that can be drawn touching the straight line at that point. Let's suppose we have a straight line like this, whose equation has been given as ax plus by plus c equals 0. Here a, b and c, they all are in uppercase letters. And let's suppose we have a point P on this line and P's coordinates are x sub 1, y sub 1. And as you have seen in previous videos, in fact we can draw infinite number of circles that will be touching this line at that point P. For example, let me draw a few circles here. Here I have drawn a few circles just for demonstration, and as you can see, you can draw infinite number of circles that will be touching this straight line at point P. And our task is to find out the general equation of this entire set of infinite number of circles that will be touching this straight line at the given point P. For the derivation, I am going to take a circle like this that touches the straight line at point P, and let's suppose the center of this circle is located at point R, and then I am taking a point Q on this circle whose coordinates are x sub 2, y sub 2. Next, I am going to connect P and Q with a straight line, and then I am going to drop a perpendicular from the center R onto the PQ chord, and then I am going to connect R with Q and R with P. So I am going to draw the two radii. And finally, I am going to drop a perpendicular from Q onto the tangent line. And let's suppose it landed at point T. From the theorem of circle, we know that the angle QPT will be equal to the angle PRS. I have already created a separate video on this topic. I have shared the link in the description. Feel free to watch that video. So here, those two angles will be equal, and let's name it as theta angle. And since RS is a perpendicular on the PQ chord, it will bisect the PQ chord. That means PS will be equal to QS. Now, what would be sine of theta? Considering the triangle PQT, we can say sine of theta can be written as QT over PQ. And then considering the triangle PRS, which is again a right triangle, we can say sine of theta can be written as PS over RP. And RP is nothing but radius of the circle, so we can write it as PS over radius if we assume lowercase r to be the radius of this circle. Now if we equate these two values of sine of theta, we can say QT over PQ is equal to PS over r, and from there we can say then PQ can be written as r times QT over PS. And then if we bring all the terms to the left hand side, we can write it like this: PQ minus r times 1 over PS times QT equals 0. Now I'm going to plug in the values of PQ, PS and QT, and let's see how that looks. The distance PQ can be written like this. Using the distance formula, we can say PQ distance will be equal to square root of x sub 2 minus x sub 1 whole squared plus y sub 2 minus y sub 1 whole squared. And then we have minus r times 1 over PS. Now what is PS? Well, PS is actually half of PQ. So I have written the same thing again. I have noted it as half of the PQ distance, which is square root of x sub 2 minus x sub 1 whole squared plus y sub 2 minus y sub 1 whole squared. And then we have another quantity which is QT. Now what is QT? Well, QT is the perpendicular distance of the straight line from the point Q, and using the formula of distance of a line from a point, we can write QT like that. It would be absolute value of a times x sub 2 plus b times y sub 2 plus c over square root of a squared plus b squared. And all of this is equal to 0. That is our original equation. And then if we multiply both sides of this equation by square root of x sub 2 minus x sub 1 whole squared plus y sub 2 minus y sub 1 whole squared, if we multiply both sides of this equation by that quantity, right, then our equation can be rewritten like this. So all I have done is I have multiplied both sides of this equation by a quantity which is square root of x sub 2 minus x sub 1 whole squared plus y sub 2 minus y sub 1 whole squared. And in the next step, I am going to try to remove the absolute value sign. So there I have to consider plus or minus. So now our equation kind of looks like this when we get rid of the absolute value sign. Now if you carefully look at 2r over square root of a squared plus b squared. From the given equation of the straight line, we know the value of a and b. The only thing unknown here is the radius of a circle. And if we take that radius as a parameter, right? If we take that radius as a variable quantity, then 2 times r over square root of a squared plus b squared can be considered a real number, and we can vary that real number. We can consider that entire thing as a parameter. So we can write k in place of of 2 times r over square root of a squared plus b squared, and this k can be any real number, positive or negative. It can be any real number, and I can simply use the plus sign k there, and then we just have to write the remaining quantity, and all of that is equal to 0, and of course k is a real number here. So now if you think about it, the equation that we have obtained so far, it is nothing but the locus of the point q. And next we are going to substitute x sub 2 by x and y sub 2 by y to get a general form of this equation which represents the locus of the point q, and the equation could look like this. All I have done is I have replaced x sub 2 by x and y sub 2 by y just to come up with the general equation for the locus of the point q, and this is that equation. And the locus of the point q will actually give us the equation of all possible circles. And here of course k is the parameter, and feel free to take any real value for k or any real number for k, and every time you will get the equation of a circle, and all those circles will be touching the given straight line at the given point P. Also we can write the equation kind of like this. In place of ax plus by plus c, we can simply write L, which is the left hand side expression of the equation of the given straight line. So this is the general equation of the family of circles that will be touching the given straight line at the given point P. I hope the entire derivation made sense. Thank you for watching. See you in the next video.